Let's talk about transformation of functions, which are going to be shifts up, down, left, right, and stretches or compressions, both vertically and horizontally. And before I get rolling, if you're not familiar with your toolkit functions or your parent functions, like what y equals x squared looks like, or y equals the absolute value of x, or 1 over x squared, x cubed, those types of things look like, make sure you go brush up on those first, because I'm going to assume that we know what those look like. So let's say we want to draw the graph of, let's start with x squared plus 3. Well, the toolkit function that I know what looks like is f of x is equal to x squared. So let's start with f of x is equal to x squared, give or take. F of x is equal to x squared. Looks like the following. It's a parabola or quadratic opening up, and it goes through the origin 0, 0. Well, what I did to it was I essentially added 3. But where did I add that 3? It looks like it's outside of this function. It's kind of over here. Outside of a function affects your output values. Output values are y values, so I'm essentially adding 3 to every single y value. If you add 3 to every single y value, right now my y value is 0 there. 1, 2, 3. Means I move up 3 in the y direction, so now I'm sitting at 0, 3. And it's just going to be essentially a copy or a shift of that moved up. So this one is g of x is equal to x squared plus 3. If you ever have had a transparency like on an overhead projector, I just shifted the transparency up by 3. Versus, let's say instead you wanted to do something like graph g of x is equal to the absolute value of x minus 2. Well, the toolkit function that I know what it looks like is, let's go with f of x is equal to the absolute value of x. We'll start there. So the absolute value of x, give or take, a little like this, and it goes to the origin also, 0, 0, and I subtracted 2. Again, where did I do it? Looks like it was outside the function out here, so I'm affecting my output or my y values, which means I'm going to go down by 2. So let me extend this axis a little bit, and if I go down by 2, instead of being at 0, 0, I'm now down here at 0, negative 2. Here's the graph of g of x is equal to the absolute value of x minus 2. Okay, so adding a positive number on the outside of a function shifts it up vertically by how many that number is, and if you subtract it, it goes down by those units. Versus, let's say, for example, you did, how about, why am I still writing in red? Let me change that to black. Let's say g of x. Let's see, what are some of my other toolkit functions? How about the square root? Let's go with the square root of x plus 5. Well, the toolkit function that I know is f of x is equal to the square root of x. Let's start there. Square root of x, give or take, a little like this. And it goes through the origin, 0, 0. And it looks like what I've done to it is I've added 5, but where have I done it? This time, this is what it means to be inside the function. I did it in here. So I added 5 to the inside, which is affecting the inputs, which are the x's. And anytime you do anything to the x's, you do the exact opposite of what it looks like. I added 5 to it. That kind of feels like maybe you go right, but you actually go left. So I'm going to go left by 5 units. So here's g of x is equal to the square root of x plus 5. And this is essentially the point negative 5, 0. The idea behind why it actually goes left is, well, if you evaluated this original function f of x at 0, it's just right here. But if you evaluate g of x at 0, what ends up happening is you end up pulling the value at 0 plus 5. So you kind of reach over here, over at 5, and then you pull it back this direction, which is why it really goes to the left by 5. Okay, next example. How about we go with g of x is equal to 1 over x minus 4 squared. Well, the toolkit function I know what looks like is f of x is equal to 1 over x squared. Give or take, that looks like this. Gets really, really, really close to the x-axis and the y-axis, but never touches it. This is f of x is equal to 1 over x squared. It has a vertical asymptote at x equals 0. It gets really, really close to it, but never, ever touches it. Minus 4. Was that inside or outside of the function? That's right, it is inside the function. It happened right inside here. You replaced x with x minus 4 instead. So that's going to do, it's affecting the x's, which is the exact opposite of what you'd think. So instead of going left, it's actually going to go right. So that means I'm going to move my vertical asymptote to the right by 4. It was at x equals 0. Now it's at x is equal to 4. And I'm going to have my function look like this now. Whew, that got a little epic over there. Do a better job than me writing that down. Okay. So there's what it looks like. You can do more than one of these at once. So for example, say you did, how about g of x is equal to x minus 4 squared plus 3. Well, f of x is equal to x squared is my toolkit function that I'm starting with. So here is f of x. It really does go through the origin, I swear. So let's just make a really big dot there. Totally goes through the origin, okay? And let's see, looks like two things happen. Why don't I start with this minus 4 first? That happened inside this function. That's x values. Does the opposite of what you'd think. It's going to go right by 4. So instead of being at 0, 0, I'm now going to be over at 4, 0, and then try to draw the same thing. So give or take, here is y is equal to x minus 4 quantity squared. Well, it's not g of x. I got one more thing to do. Get a plus 3, and if you notice here, that's outside of this function. Outside is outputs, that's y's. It does exactly what you think. Plus 3, that's going to go up. I'm going to be sitting right here at 4, 3. So give or take, there is my g of x. Light's having a hard time. You can do it. There we go. G of x is in. The red. So those are vertical shifts and translations, as well as horizontal shifts and translations. But you can also stretch and scale. So those are going to be with multiplications. Let's say I was working with g of x is equal to, how about 2x cubed? Well, y, or f of x, is what I have been using in this video, so I'll try to stay consistent. It's going to be my toolkit function, x cubed, give or take, looks a little like this. So here's my y equals x cubed, goes through the origin. And it's a little hard to tell what's going to happen here. So another point on this graph, let me note, is going to be 1, 1. Well, what I did to it is I multiplied by 2, and I did that multiplication outside of that function. So outside of the function affects the outputs. Those are my y values. So I'm just going to take every single y value and multiply by 2. So this y value right here is 1. So if I multiply that by 2, 1 times 2 is 2. Didn't do anything to the x, so here's 1, 2. That's why I say the origin wasn't going to help me much, because 0 times 2 is still 0, so it still goes through there. What you'll also notice is if I kind of start drawing this, is this distance that I had right here from the x-axis on my new function where I multiplied by, oopsies, 2, there we go, it's twice that distance. So you're just stretching the distance by 2 from the x-axis, which is why it's going to be down here. Okay, so here's my g of x is equal to 2x cubed. Next example, how about if instead we had, how about g of x is equal to the absolute value of 2x? Well, my toolkit function that I know what it looks like is the absolute value of x. So let's start with that. Give or take, it looks a little like this. And again, it does go through the origin, but I don't think that's going to be the most useful point to track through. So let me put another point on here. Let's go with 1, 1. Well, what did I do to it? I multiplied by 2 on the inside of that function. So it's the inside, so it's the inputs. So those are x's. And again, x's are going to do the exact opposite of what you'd think they're going to do. You'd think you'd multiply by 2, but really in the end, it's going to cause you to do the opposite of multiplication, which is dividing by 2. So I'm going to take every x value and divide by 2. So here's my x value 1. I'm going to divide by 2. Well, that gets me right here to a 0.5, 0. No, a 0.5, 1, excuse me, 0.5, 1. And again, a half of 0 is just 0, so I'm still going through there, so it does this. And you can see again that originally I had this distance from there to the y-axis this time, and multiplying by 2 on the inside caused this distance to now be half of what it was. So do the same thought over here, and it looks like this. So here's my g of x is equal to the absolute value of 2x. You can combine shifts, translations, stretches, compressions together. So let's step up and let's go with g of x is equal to, how about 2 times x plus 1 quantity squared minus 3. I'm going to start with f of x is equal to x squared and work from there. Now, just like order of operations, make sure you do the multiplication things first. Multiplication comes ahead of addition or subtraction in the order of operations. So, first thing that we're going to work with is essentially the 2, because 2 is being multiplied. This 2 is the one I'm talking about right there. It's multiplied. The plus 1 is an addition. The minus 3 is also a subtraction, technically. Okay, that 2 is outside of this function, so we're going to affect the y values. So it's going to stretch the y values by a factor of 2 because y's do exactly what you think they're going to do. So I started down here with, say, a point like 1, 1, and when I multiply that y value by 2, it's going to be 1, 2, which means I'm just doubling the distance. My graph is from the x-axis in this case. So here's y is equal to 2x squared. From there, it looks like plus 1 or minus 3. I can deal with either one of them. First, I'll just go with the plus 1. Plus 1, right here, is inside this function, so I'm going to be affecting the x value, so they're going to do the exact opposite of what you'd think they would, and they're going to go left by 1. So my origin, 0, 0, is now going to be over here at negative 1, 0, and the other point that I was tracking through, which is 1, 2, is now going to be at 0, 2. Picture's getting busy. So there's my 2 times x plus 1 squared. Last thing I have to do is this minus 3. This minus 3 that I have sitting here is outside of this function. It's sitting right here. So it's y values because it's the output, which means it's going to go down. So this negative 1, 0 is going to go down by 3. So it's now at negative 1, negative 3. And this 0, 2 is going to come down 1, 2, 3 places. So now it's sitting here at 0, negative 1. So give or take, don't pay too much attention to where my intersections are. It's going to look exactly like this. So once you now know what a graph looks like, it's a lot easier to talk about the range, because we usually have an easier time if we know what the graph looks like to talk about the range. So it looks like this one has a range, starts at negative 3 and then heads on to forever. And another type of thought that you could do with these shifts and translations, let's say you were given a point originally on a graph. So let's say, for example, that you know negative 8, 1 is a point on the graph of, let's say y is equal to f of x. And we want to find the point that will be on, how about y is equal to f of 10x minus 7. Well, I'm starting with negative 8, 1. That's on y equals f of x. The first thing I'm going to do is I'm going to deal with this 10 in here because that 10 has multiplication. That 10 is inside the function. That's affecting the inputs or the x values, which means they do exact opposite of what you'd think you would. It looks like you're multiplying, sorry about that, 10. So you're going to actually divide by 10. This is going to be a new point on the graph of y equals f of 10x. And then the last thing we have to do is that minus 7. That minus 7 is outside this function, so that's affecting y values or the output. So you'll do exactly what you think you should. You'll take 7, subtract that from your y value. So this is going to give me negative 4/5 and then negative 6. So this would be a point on the graph of y is equal to f of 10x minus 7.